Bismillah, alhamdulillah, salatu wassalamu ala rasulillah. Today we will continue, inshallah, section 3.6. This section, as you know, it is about rational functions. Mainly, we need to pay more attention to asymptotes because the rational functions are not new for you. What is new is the concept of asymptotes. Let's go quickly about what we did in the previous class, just to refresh your memory. The rational function, it is the function that has the form of a ratio between two polynomials, a polynomial over a polynomial. The basic one is the reciprocal function, 1 over x. Its graph, it has one vertical asymptote, two asymptotes, one vertical and one horizontal. For 1 over x, x-axis is the horizontal asymptote and y-axis is the vertical asymptote. In general, what we mean by asymptotes, you need to understand this concept not only for this course, for other courses as well. So let me ask you this question here. X equals A. Of course, it is a vertical line. So this is a vertical asymptote. So x equals A is a vertical asymptote if what? Look here. Let me go back to the definition. What is going on? It is not enough. Yes, you are right, Abdulaziz. It is when the function is not defined. But we will see today some examples. The function is not defined, but it is not vertical asymptote. Okay, so you have to distinguish between these two cases. So first of all, let's look here what happens when x approach. Let me change the here. When x approach A from the right or from the left, x goes to where? The y goes to where? Y goes to infinity, to positive infinity. Here, when x approach A from the left or from the right, the function y goes to where? To negative infinity. So the answer for this question, x equals to A, is a vertical asymptote if what? If f of x, the y, approach positive or negative infinity as x approach A from the left, or you will study this in math 101 as this: limit of the function when x goes to A from the right or from the left equals to positive or negative infinity. This is the meaning that you have a vertical asymptote in this case. Now, y equals B is a horizontal asymptote if what? If the function approach B as x approach positive or negative infinity. The definition is here. Look, it is an end behavior. We are just asking about eventually what will happen eventually. So in terms of limit, this means what? Limit the function when x goes to positive or negative infinity equals to what? To B. B here is a fixed number, a finite number, not infinity. If it is infinity, it is not a horizontal asymptote. Okay, I rewrite this here in another way, but it is the same idea. We mentioned yesterday that the graph cannot intersect any vertical asymptote, but for the horizontal, they may intersect each other. Any rational function of this type, linear over linear, can be obtained by the transformations of the function 1 over x. So just by shifting, stretching, and reflecting. These some examples that we had yesterday. Pay attention about the domain, the range, the vertical asymptote, the horizontal asymptote in this case. Of course, when we have horizontal shift, the horizontal asymptote will stay the same, but the vertical will be changed. Like here we have horizontal shift to the left. So the vertical asymptote is x equals 3, not x equals 0. This is the type that we, I think, stopped at the last class, how to sketch the graph or find the vertical and the horizontal asymptote of such function. To do that, you need to use the long division to know, because this is linear over linear, so it comes from the function 1 over x. It is coming from the transformations of 1 over x. To know exactly what happened, in fact, you just use the long division. So this will be 3, the quotient is 3 plus the remainder, which is negative 1 over 1 plus x, which is negative 1 over x plus 3. So shifting 2 units to the left, reflecting in the x-axis, and then shifting up 3 units. Look here at the graph. Because of the reflection, of course, it was here. Now it will become in this place. We will learn today another way to sketch the graph of such function like this. You can, of course, use this one or the one that we will show you. Yes.
So I can obtain the vertical asymptote from the denominator.
From the zeros of the denominator, if there is no common factor between the numerator and the denominator.
So when he asks me about the vertical asymptote, I can obtain it without doing the long division.
Yes, of course. No, we don't do the long division here to obtain the vertical asymptote. No, we are doing here to sketch the graph. How to sketch the graph?
He asked about specific things, so I don't have to do the
Of course. Also, in the previous class, we have studied this function 1 over x squared. Its graph is this way, and it can be used to obtain other graphs like this one. Just shift, it is coming from the shifting of 1 over x squared to the left 2 units and then down 1 unit. Now, today, our class starts from here. Now, you know what we mean by what is the definition of the vertical asymptote and the horizontal asymptote, right? Now, here in this slide, we have a method of finding the asymptotes of rational functions. If your function is rational, this is how to find the vertical and the horizontal asymptote. What is it? Since it is rational, so it is polynomial over. So let's assume that the polynomial in the numerator, it is of degree n, and the polynomial in the denominator, it is of degree m. Now, the vertical asymptotes are simply the lines x equals a. What is a? A is a 0 of the denominator. So always, if there is a vertical asymptote, it will be a 0 of 1 0 of the denominator. Okay. Now this is for the vertical asymptote. For the horizontal asymptotes, we have 3 cases. If n less than m, what is that? If the degree of the numerator is less than the degree of the denominator. Look at the beauty of mathematics. This long line statement, it is just shorted if n is less than m. Then what? Then R, this polynomial, has horizontal asymptote y equal 0. Good one. Always, whatever the degree of the numerator, just we need the degree of the numerator to be less than. In all of these cases, y equals 0, which is the x-axis, is the horizontal asymptote. Just to remember this, remember the reciprocal function. 1 over x. The degree of the numerator is less than the degree of the denominator, and the horizontal asymptote is y equal to 0. Now, if n equals to m, if they are of the same degree, what will happen? The horizontal asymptote will be y equals a n over bm. What is that? The leading coefficient over the leading coefficient. This is if they have the same degree. Now, if the degree of the numerator is greater than the degree of the, if the degree of the numerator is greater than the degree of the denominator, then no horizontal asymptote. And indeed, let me, I think especially our section 26, I'm talking to an excellent students. So I think you know why this will be why it will be here 0, why here it will not exist. Why it will be 0? Because if you have a polynomial of degree less than the degree of another polynomial, when the horizontal asymptote is about what? Is about when x goes to positive or negative infinity. So if you have think about any polynomial with degree less than a polynomial in the denominator. Let me give you an example. X squared plus, let's say x squared over x to the power 3 plus 1. What do you think? What will happen when x is very, very, very big? When x goes to infinity? This will behave, it will be like x squared over x to the power 3. The one here, the effect of 1 will be almost 0. So infinity plus 1, it is infinity. So this, there will be similar to 1 over what? 1 over x. And this is, of course, when x goes to infinity, it will be what? 0 when x goes to infinity. This is why we will have y equal 0 always, because it is a limit, the limit here. Now, for this case, it is the opposite one. When you have x to the power 3, for example, or x to the power 3 over x squared plus 1. Eventually, when for large values of x, this will behave like what? X to the power 3 over x, which is, will be what? So what will happen for x if x goes to infinity? If x goes to infinity, this will go to where? To infinity. So this is why no horizontal, because both, in this case, the function will go to infinity when x goes to infinity. Y and x, both of them goes to infinity or negative infinity. So let's take an example. I think it will be easier to have examples about this. Yes.
Do we have
More than, is it possible to have, good question from Hassan. Could we have more than one horizontal asymptote? For the vertical, the answer is yes, of course. You may have m, if the degree here is m. You may have m vertical asymptote. But for the horizontal, who can answer this question? We can only have one. Why? It is one or none?
Yeah, it is 0 or 0. So,
0 or this?
yeah, I mean, you said that.
Okay. Why? Because you have only one leading coefficient over one leading coefficient. So how can you have two, ya Hassan? So it is one leading coefficient over the same leading coefficient. Okay, or 0. For example, what is the horizontal asymptote of this one? What is it? No. Y equals to 2, Abdullah. Excellent. 2 is a number. It is not an asymptote. The asymptote is a line. So it is y equals to 2. You will have in the choices y equals to 2 or x equals to 2. Which one you will choose? Okay, so the horizontal asymptote is y equals to 2. For the vertical, what to do to find the vertical asymptote? Find the zeros of the denominator. How to find the zeros of the denominator? Factor. So always I advise you to factor both. If you can factor both numerator and denominator. Okay, then decide. So the zeros of the denominator are x. Try your best. If it is prime,
I mean, if I reach the point that the denominator is 1, so there is no vertical.
yeah, no vertical. If there is a vertical asymptote, it will be one of the zeros of the denominator. Is that clear? So the vertical asymptote is the line x equals 1. The horizontal asymptote is the line y equals 2. Look, if you sketch the graph of this function, look how it looks like. And do you notice something? There is y-intercept. Why? No problem. Of course there is. Do you how it is related to the graph of 1 over x squared? It is obtained from the graph of 1 over x squared. Just it is shifted 1 unit to the right and 2 units up with some stretching and shrinking maybe. So if you want to know, divide by the log division, and you will know how it is obtained from 1 over x squared. But the good news that graphing such kind of function is not required from you in this course. What you are supposed to know in this course is the case of linear over or constant over linear, which is in fact special case. So let's generalize it. Linear over. This is only what you need to know how to sketch the graph. Yes.
Why is the horizontal line is above the asymptote? Must be beside.
Not beside. Who said beside? It is asymptote. The horizontal asymptote. Why it is beside? It should be either above or below.
Yes, but it's on the asymptote. The horizontal. The graph.
No, the graph it is on. They might intersect, yeah, Rashid. They may intersect each other. We will see that in the next. If you want to know this one, what is the horizontal asymptote? Y equals to, what is the function? What is y? What is the y of the function? 2x squared minus 4x plus 5 over x squared minus 2x plus 1. How to know that the graph of the function intersect the horizontal asymptote or not? Two graphs. When you have two graphs, a function f, another function g. What will happen at the intersection point? They will be the same. F will be equals to what? To g. So we will equate them. Equate this with what? With 2. If you have a solution, if you can find the value of x, then there is an x-intercept. If it is 1 or 2, it depends. If there is no, if you got a false statement, there is no intersection point between the graph will not intersect the horizontal. So let's solve this for x. What we will do? Cross multiply. It will be 2x squared minus 4x plus 2. Is that right? So you will cancel this with this, this with this. 5 equals to 2. Is this possible? If 5 equals to 2, these two graphs will intersect each other. But unfortunately, 5 is not 2. So these two, this graph, the graph of this rational function, will not intersect its horizontal asymptote. We will see some of them, they will. They intersect. Find the vertical and the horizontal asymptote of this one. Which one is easier to start with? The horizontal. Y equals 3 over 2. It is y equals 3. To find the vertical, you need to do what? Factor. It is, I advise you always to start with factoring and then do what you want to do. Anything else. So here, we have 2 zeros of the denominator. X equals a half and x equals -2. These are the vertical asymptotes. For the horizontal, you already mentioned it. It is the line y equals 3 over 2. What about this function in A? What is the horizontal asymptote? Y equals 0. Y equals 0. Why it is y equals 0? The degree of the numerator is less than the degree of the denominator. So y equals 0 is the horizontal asymptote. For the vertical asymptotes, x equals the lines, x equals a half and x equals -3. For the next one, for this one, 2x plus 1 over x minus 3. So the vertical asymptote is here. The vertical asymptote is x equals to 3. The horizontal asymptote is what? Y equals to 2 over 1, which is 2. By the way, this is a good example to show you something here about does the graph of this function intersect its horizontal asymptote? What we need to do to check? Equate them. This y here, it will never ever intersect its horizontal. Any linear over any linear will never ever intersect its horizontal. You can show it in general. Let's show it for this one, and then we will see for all in general. I will leave it for you. So this will be like this, right? If 1 equals -6, they will be intersected each other. Now, in general, you can show it, Shabab, in general. If you have ax plus b over cx plus d, what will be the horizontal asymptote? A over c. Try to solve this equation. So it will be ax.
So we should have b equals to b.
Yes. And in this case, you have what? You have this line. It is the line. The graph is the line. Okay. So what we conclude from this? The no intersection points. So the graph of linear over linear does not intersect its horizontal asymptote. No, we have agreed about that. It is undefined. How it will intersect it? It is undefined at that number. Yes, it is undefined. It is one of the series of the denominator. Now, how to sketch the graph of this one? How to graph? Yes, excellent, Hassan. So method number 1 is the method that I told you in the previous class. Do you remember it? What is it? Let me solve it here by the method number 1, which is the one that we did yesterday. What you will do? You will divide. So it will be what? 2x minus 6. It will be 0 plus 7. So now our function 2x plus 1 over x minus 3 will be equals to the quotient, not 7, 2. Please. You did this mistake, by the way, in the quiz of this previous class. Over x minus 3. Now this function, it is in fact obtained from the graph of 1 over what? From the graph of 1 over x, but shifted what? 3 units to the right. So now the vertical asymptote is at 3. And it is vertically stretched by 7, whatever. It will not change the graph, the shape, the main shape of the graph. And what is the horizontal asymptote? It is shifted up. It was the x-axis. Now it is shifted up 2 units, so it will be here. Is there any reflection? No reflection. So the same shape, just it is stretched. It will be like this. If you want to sketch the graph exactly, you need to find the x-intercept and the y-intercept. So initially, this is the graph. Okay. This is one way. The another way is what? So let's say this is method 1. This is method 2. What is method 2? Find the vertical asymptote and the horizontal asymptote. What is the vertical asymptote? X equals to 3, please. And the horizontal asymptote? Y equals to 2. Now go sketch the graph. Start with what? With the vertical, then the horizontal. Now the graph, again, you know it is linear over, so it is coming from 1 over x. So it is either here like this or like this. How to know? Because we don't know here if there is a reflection or not. How to know? Why? No. My question, Nawaf, is the function. It could be like this if there is a reflection. If there is no reflection, it will be like here. How to know? Because the function is positive. Do you remember the previous one? There were a reflection and it wasn't. Let me show you the one. Where it is? This one. Is that it was clear that there is a reflection from here? And there were a reflection. Right? Yes, there is a reflection, but it is not clear. No, it is not about. It could be. It is neither, by the way. It is neither. This kind of functions is neither. If you have, of course, the ax in the b is not 0 in the denominator. Let's go back here where we are. We are sketching the graph of this function here. So now, how to know in which quadrant? Let's say. We lost the x-axis. To know, you need to use test points. So use a point here on the right or on the left of the vertical asymptote and see what will happen. It is better to think about the x-intercept and the y-intercept. For example, when x is 0, this is the y-intercept. So when x is 0, what will happen? Negative third here. When y is 0, what you will get? This will be 0. Here it is. So the graph will be like this, here and there. You will know that it will not be in these two places because it is just 1 over x, but it is shifted up or right, down or left. This is the graph. Finally, this is how the graph looks like. So now you can use any method you prefer. Use the vertical, find the vertical and the horizontal asymptote, then use test points on the right and the left. The x-intercepts are good points to be used. Find the intercepts, the asymptotes, and the domain of this function. Let's start with the intercepts. What you should do first? Factor. The first thing or the best thing to do is to factor. Factor both numerator and denominator. This will save your time because now if you want to find the x-intercept, what you will do? You will put y equals to what? Y equals to 0. So the whole function will be equals to what? To 0. This means that the numerator is 0. So you already factor the numerator. This will save your time and you can, of course, factor it. So now the x-intercepts will be the zeros of the numerator, which are a half and negative 4. For the y-intercept, you will put x equal to what? x equal to 0. So they will be the value of the function at 0, are at 0. And it is easier to be found from here, not from the factored form, from the original form. It will be what over what? The constant coefficient over the constant coefficient, always in this case. So it is 2. Excellent. What else? The asymptotes. Let's start with the vertical asymptotes. What they are? X equals 1 and x equals negative 2. The horizontal, y equals 2. The domain, all the real numbers except 1 and 2. This is how the graph looks like. Again, this is just for your kind information. It is not required from you to sketch the graph. But I want you to notice something here. What you can say about this? Yes, the graph intersects its horizontal asymptote at 0. How to show that algebraically? Algebraically, you will do what? You will equate your function with its horizontal asymptote. What is it? 2. So it will be 2x squared plus 7x minus 4 equals to 2x squared plus 2x minus 4. Cancel, 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 cancel. You have 7x equals to 2x. What is that? 5x equals to 0. This is what? X equals to 0. So the intersection is at x equals 0. You know that if you want to find the coordinates, it will be 0 and what? 0 and r at 0, which is what? 0 and the y-intercept. This is the intersection point. Another example. We need a new type of example. Oh, it is the same. Okay, the intercepts, you will factor. The intercepts, what are the x-intercepts? What? Rashid. The x-intercepts. Both y equal to 0. Here, y equal to 0. So the numerator, the zeros of the numerator. What about the the y-intercepts? 0 and negative? Are you kidding? The y-intercept, you will put x equal to 0. When x is 0, what will happen? R at 0 will be negative 4 over 0, undefined. So there is no x-intercept. The graph does not intersect the y-axis. Excellent. The asymptote, the vertical asymptotes, 0 and negative, x equals 0 and x equals negative 1. And the horizontal asymptote, y equals a half. This is the graph. And this graph, of course, what do you think? It intersect or not? Not from the graph. But it equals to what? A half. What you will get? 2x squared minus 8 equals to 2x squared plus 2x, right? So what is it? Negative 4. It is. What about this one? The x-intercept. First of all, what you should do? Factor first. X-intercepts. Negative 21 over 5. The zeros of the numerator. The y-intercepts. What x equals to 0? The leading coefficient over the leading coefficient. The vertical asymptote. Vertical asymptotes. Why you say y when you say vertical? Vertical asymptotes, x equals negative 5. Be careful. And the horizontal asymptote, y equal. Who said y equals 5? The degree of the numerator is less than, so it is y equals to 0. Be careful. Be careful. And this graph intersects its horizontal asymptote, by the way. The horizontal asymptote is the x-axis. You can find it algebraically. Just put this equals to what? To 0. And you will get what? You will get the x-intercept. Now, what about the case when we have a common factor between the numerator and the denominator? All the rational functions that we had before, there is no common factor between them. Now, if there is a common factor between the numerator and the denominator, we may cancel that factor, but only for those values of x for which this factor is not 0. We should consider the domain where we are working. What are the valid values for x? In this case, the graph has a hole at that point, or a point of discontinuity. For example, x squared minus 4 over x minus 2. What is the vertical asymptote? Why there is no vertical asymptote? No relationship between the degree and the vertical asymptote. Be careful, please. We discuss the degrees when we talk about the horizontal, but I'm asking about the vertical asymptote. If there is a vertical asymptote, it will be what? It will be a 0 of the denominator. So what is the vertical asymptote here? X equal? It is not. It is not. There is no vertical asymptote here. Let me repeat what I said. If there is a vertical asymptote, it is a 0 of the denominator. But it doesn't mean that the 0 of the denominator is a vertical asymptote always. Here we have a common factor. We need to cancel it, then decide about the vertical asymptote. So here you should do what? Factor first. So when you factor, you will get x minus 2 over x minus 2, which can be cancelled, right? But under one condition, x is not 2. So you can cancel it, and x is not 2. Of course, it is not 2 because the domain of this function is all the real numbers except 2. Now, look at the question. He asks about sketch the graph of this function. And this is not linear over linear as we agreed. So, but in fact, it is easier than that. It is linear only, not linear over linear. So to sketch the graph of this function, the graph of this function is the same as the graph of this function, except at 2. What is going on at 2? Why a hole, not a vertical asymptote? It is not defined. A hole or a vertical asymptote. In both cases, it is not defined.
So because it's the one
Not approaching 2, approaching 4.
it's not increasing or decreasing.
I am looking for an answer. Who can give me this answer? Look, let me show you the graph. Now, what you will do, you will sketch just this graph with a hole at 2. Now, what will happen when x approach 2 from the left or the right? Abdulaziz bin Ubaid was very close from the answer. When x approach 2 from the left or from the right, the y approach what? 4. So what? Why there is no vertical asymptote? What will happen if we have a vertical asymptote? In the case of vertical asymptote, when x approach 2 from the left or from the right, the function will get crazy. It will go infinity or negative. This is not the case here. You will study more about this in the limits in Math 101. Is it clear? Discontinuity, it is removable. Removable discontinuity. You can redefine the function to remove this kind of discontinuity. Okay, what about this one? Sketch the graph of this one. What you will do first? Let me ask you, what are the vertical asymptotes? What you should do before deciding about the vertical asymptote? Factor. And then cancel the common factors between the numerator and the denominator. Now you can answer. What is the vertical asymptote? X equals 0. This is a vertical asymptote. What about x equals 3? The function is not defined at 3 and at 0. But at 3, there is a hole. At 0, there is a vertical asymptote. So the graph of this function is the same as the graph of this function, just with a hole at 3. Look here. There is no vertical asymptote because the graph will not go to infinity or negative infinity when x approach 3. What about this one? Factor first, cancel. The graph of this function is the same as the graph of x squared, but with a hole at 2. The last part of this section, we have time. Good. The last section or the last part of this section is about slant asymptotes or oblique asymptotes. What they are, how to find them. Now, what are the types that we have studied so far of the asymptotes? What are the types? Horizontal or vertical. Now, there is another type for many functions. There are many functions. They have this type of asymptotes. It is a line that is not vertical, not horizontal. It is a line with positive or negative slope. So it is a line, but not vertical or horizontal. Now, the graph will eventually will be the same. The graph here, the graph in the middle here, it could do whatever, but eventually it will be like a line. It will behave like this line. Here it could be anything, whatever, but eventually it will be like this. This kind of lines, we call them slant asymptotes. So the function at infinity behaves like a line. Now, for the rational, because this section is about rational functions, so we will focus on rational functions. When you have a rational functions, when it has slant asymptote. Yes. So if you have a polynomial over a polynomial p over q, a rational function, and the degree of the numerator is one more than the degree of the denominator, then in this case we can use the long division, the division algorithm, to express it in this way. P over q will be a linear. Why it will be linear? If you have of degree 3 over of degree 1, of degree 2, this is when the numerator is 1 more than the degree of the denominator. In this case, the result will be what? Will be linear. Whatever here, but it is linear. So here it is. This is the quotient of the division, plus the remainder over the divisor. Okay. Now, the degree of the remainder always less than the degree of the divisor, right? And a is not 0. So we have a line because it is coming from dividing the leading coefficient by the leading coefficient. Now, what will happen when we talk about the asymptote? When we talk about the asymptotes, ya shabab, we talk about when x goes to what? To infinity or negative infinity. What will happen to this term when x goes to infinity or negative infinity? When you have r of x over q of x, and the degree of r is less than the degree of q. So this will goes to what? To 0 as x goes to positive or negative infinity. Why? Just remember 1 over x. Remember the case of the horizontal asymptote when x goes to infinity and negative infinity. But here, of course, so at infinity, the effect of this term is eliminated. So at infinity, the function will be similar to this. They will behave, they will be like each other at infinity. And this line, so just you will put it y equals to x equal a, and we will call it slant asymptote, or sometimes they call it oblique asymptote. Find the slant asymptote of this function if it has. Is there a slant asymptote for this one? It has or not? First of all, before dividing.
Yes, yes.
Why it has? The degree of the numerator is exactly 1 more than the degree of the denominator. So it has. So what we will do, we will divide by using the long division. Now, what is the slant asymptote? What? What is the slant asymptote? No. Y equals to x minus 1. This is a line. Okay. Now, look, if you sketch the graph, if you divide, this is what you will get. If you sketch it, you are not supposed to sketch the graph, but look what happened. At the beginning here, they are, of course, different from each other, but eventually, look, the graph, if you look at them here, you cannot distinguish between them. They are like each other, asymptotes to each other. Okay? Any question, Shabab, before going to the recitation exercises? There is no question? Yes.
We are not required to sketch the...
Yes, linear over linear only. One of your colleagues in the previous class, he asked about, does the graph intersect the slant asymptote? Is it possible? Why? If you said no, why? If you said yes, why? Again.
Maybe in the middle. Or the end.
Yes, it might, by the way. The graph may intersect its horizontal asymptote. And you can think about like what? Like x cubed minus 1 over x squared plus 1, let's say. Is there a slant here? What it will be? Now, I don't know if it will work, but let's try this. So you will have here x to the power 3 plus x, right? So what we have here? Negative x minus. We will stop here. That's it, right? Now you will have what? Y equals to what? To x.
Negative.
Y equals to x is the slant asymptote. This is the slant asymptote. The quotient, this is the slant, let's call it, is a slant asymptote. Now, does the graph of this function will intersect the line x, the line y equal x? Look at it, we will see. So you will put x minus 1 over x squared plus 1. You can use Shabab also graphing calculators to check that. So what you will have here, x cubed minus 1 equals to x cubed plus 1. Is that right? Plus x. And this means what? This will be cancelled and you have x equals what? Negative 1. They intersect each other at negative 1. So the answer is yes, they may intersect. Again, this is about eventually, like the horizontal. What happens eventually at infinity and negative infinity, not at some small values of x. Okay, I'll give you just this question to think about it while I'll take the attendance and distribute the grades of quiz, the last quiz. It is so easy just to check your understanding. So let's solve it and then distribute. I think we have time. Yalla, think about it. Sure. So from the graph, from the function, what is the horizontal asymptote?
Y equals 2 over 3.
Y equals a over 3. But it is given that it is y over what? So here 2 over 3 will be equals to a over. From this, a equals what? 2. Just multiply both sides by 3. So we did find a. Then what is the x-intercept? The x-intercept, just you will put y equals to what? To 0. So 2x minus 5 over 3x minus 4 equals to 0. The numerator is 0. X is 5 over 2. And the answer is 5 over 2, B. This is enough for today. We will continue, inshallah, next class practicing more recitation exercises. And also we will practice more on 3.5 and chapter 3 as well.